The first thing we need to understand is how multiplication and division work. So if we multiply two numbers together, 8 times 6, we're combining factors. 8 is a factor, 6 is a factor, and we get 48 if we combine that together. Now division, on the other hand, is removing factors. So if we have 6 divided by 3, well, we know that's 2, so we can do that in head. Otherwise we can do 6 divided by 3 equals 2 times 3 divided by 3. Cross out the 3's, and we're left with 2. Yes, we got rid of factors when we divide. We combine factors when we multiply. Now we're going to combine those together. So I'm going to give you a problem. I'm going to say, what's 8 times 6 divided by 3? Well, if we do our appendices, then we know that we do 8 times 6, which is 48. And then we do 48 divided by 3 equals some number. Okay, let's see if we can find an easier way to do this. Okay, so we're going to do the same problem. We're going to say 8 times 6 divided by 3 equals some number. So how do we calculate that? Well, we take 8 times 6. What's 8 times 6? It's 8 times 6. And divided by 3. What's 8 times 6 divided by 3? It's 8 times 6 divided by 3. Well, do we see any numbers in here that we can work with? Well, this is equal to 8 times 2 times 3 divided by 3 equals some number. And now we can easily get rid of the 3's because division is simply removing factors. And now we're left with 8 times 2 equals some number, and multiplication is easy to do in your head. So that's 16. And now we've solved it. So let's talk about what we did here. We have 8 times 6 divided by 3 equals some number. Okay, and our first step, did we do any computation? No, we simply reorganized the problem into this. We're just doing bookkeeping. And then our second step of the problem, we did this. We took the 6 and we turned it into 2 times 3. We turned it into smaller numbers. Math gets hard as you get bigger numbers, so if we can make things smaller, then it's easier to do. And then in our third step, all we did is cross out a couple numbers. We didn't have to think about it, we didn't have to compute anything, we just saw we had this number on top, same number on the bottom, we get rid of them. And in the last step, we had to multiply two numbers together. And that is it. Let me show you another example. So now we've got, let's say we want to do 2/3 plus 1/4 is equal to some number. Now the way we solve this, if you look at the bottom and say, well, we got 4 here, so I'm just going to, I don't care what that number is. I'm going to put that over here, and I'm going to do that. 4 divided by 4 is 1, so we're not changing the value. Then over here, we've got this 3 here. I don't care what it is. I don't care that it's a 3. I just see this number. I'm going to write it here and put it over itself and go like that. So at this stage, you don't care what the numbers are. You're just following the pattern. Take this number on the bottom, multiply the other number by it on top and bottom from that 3 over there. Now we've got 4 times 2 plus 3 times 1 all over 4 times 3. So again, we're not doing any computation at this point. We're just reorganizing the problem, making it simpler. So now we've got 4 times 2 is 8, plus 3 times 1 is 3, divided by 4 times 3 is 12. 8 plus 3 is 11. And that's all over 12. So yeah, what we're doing is we're just showing that we're not prematurely combining values. And this is very important when we get to the next step. So now I'm going to show you the classic way of solving this type of problem. So we've got 2 over 3 plus 1 over 4 equals 3 over x. I should switch that. X over 3. We don't want to make it too hard now. Alright, so the classical way of different denominator, classical way of doing this, say, well, we take all the denominators. 2 4, and 3. We multiply them together. So we got 3 times 4 times 2. 3 times 4 is 12 times 2 is 12 times 2 is 24. Now we take 24 times 2, 24 times 1, and 24 times x. And now we get 24 divided by 3 is 8, so we get 8 times 2 plus 24 divided by 4 is 6 times 1 is 6. 24 divided by 2 is 12 x. We get 8 times 2 is 16 plus 6 equals 12 x. And notice we did a whole bunch of computations. Let me show you an easier way to do this. So we're going to start with the same problem, and now we're going to look at it and say, okay, well, what's the common denominator of this? So we got to take the 2, the 4, and the 3. We're looking for all the different numbers. So we got this 2 times 3 times 4. What's 2 times 3 times 4? Well, it's 2 times 3 times 4. We're not going to multiply them together right now. So let's take this 2 times 3 times 4 and multiply it over here, just like we did in 24 before. Okay, now I can cross out the 3's. Here I can cross out the 4's. Here I can cross out the 2. And now I've got 2 times 4 is 8 times 2 is 16, plus 2 times 3 is 6, equals 3 times 4 times x, which is 12x, which is 22, equals 12x. So we've gotten rid of the fractions without doing any computation here, by just recognizing that division is removal of factors. So why would we want to combine that together when we're just going to have to break it apart again? So let's break down what we did here. So we wrote out the problem. We took our unique denominator values and put them off to the side here just so we can see what they are. And then instead of combining them together, so we didn't do any math at this point, we just looked for unique numbers, copied them over here, and then instead of doing any math here, we just take these numbers, we copy them here, here, and here. So at this point we haven't done any actual computation. And then the next step is simply to cross out the numbers that match, which is basically preschool stuff. Okay, it was 4 here, cross it out. 3 here, cross it out. 2 here, cross it out. So we haven't done any computation at this point. And we've eliminated the fractions without any computation. And now we're left with multiplication and addition, which are very easy to do in our heads. So the test of this is the question, does it always work? If it doesn't always work, it's not math. It's fake math. So let's see if this is real math or fake math. So we're going to come up with a ridiculous problem. We're going to have A over B plus C over D equals X over E. And we want to solve for X. So let's do our process. So we got to look for our denominators, our unique denominators. We got B times D times E. Well, what's B times D times E? It's B times D times E. They're letters. You can't combine them. Okay, so then we take these, we write them over here. B times D times E, B times D times E, B times D times E. Okay, again, crossing out the matching letters. Notice that when you put it into letter form, it becomes very obvious what you're doing with the numbers, which also demonstrates why it works. Okay, so now we've got D times E times A plus B times E times C plus equals B times D times X. So we did the exact same thing we did with the numbers, except we did it with the letters, which explains why it works with the numbers. So let's break down again what we did here. So we had our original problem. We took our unique denominator values. We multiplied them together off to the side. And then we just took what we had and we multiplied that value times each of the components of this equation. We then crossed out the matching letters. So at this point we haven't done any computation. With literal equations, it's not possible to do computation because there's just letters. You can't combine them together. It doesn't make any sense. And then your fractions are removed. and you're left with multiplication and addition, which again you can do in your head, but because these are literal equations, you really can't go a whole lot farther than this. Now what's actually interesting is that if you do it with the literal equations first, then you can go back to the number. You have that recognition that, oh, this actually works with numbers as well, and not only does it work with numbers, it makes working with numbers significantly easier. But in school you actually learn the number way first, with the hard way combining and then breaking things apart, and then you learn literal equations, and that connection is never made from this back to numbers. And now that you know this, you can make that connection back to numbers and simplify your life significantly. Okay, so we want to show that this always works. So let's get something more advanced than just letters or just numbers. Let's combine. So let's say we've got 2 plus 5 divided by x plus 3 equals 5x. Okay, so we've got that fraction there. We've got an equal sign. That means we probably can do this. So what is this really? This is 2 over 1. This is really 5x over 1. So what are our unique denominators? Our unique denominators are 1 and x plus 3. So we're going to take 1 times x plus 3. We're going to put it in parentheses because that goes together. And I don't care. You're looking at that and going, well, that's a 1. We can get rid of it. I'm going, well, I'm just copying numbers. I'm not thinking about that. That is not in my head right now. That's thinking way too hard about this problem. So it's just 1 times the quantity x plus 3. So I'm going to go over here. I'm going to write that over here. 1 times x plus 3. 1 times x plus 3. And now, just like before, we cross out the 1. We cross out the x plus 3. We cross out the 1. Now we've got x plus 3 times 2 plus 1 times 5 equals x plus 3 times 5x. We're left with multiplication and addition, and we haven't done any computation. All we've done is we looked for the unique numbers down here. We 1 and x plus 3, put them over here. We didn't do any combining. We didn't think about that 1, that maybe we could get rid of it. And the reason we didn't think about that is because I need that number there for the rest of the problem to make sense. I'm going to take this, put it over here, here, and here. Again, not thinking about it, just copying it. I don't care what that is, I'm copying it here. Since I left that 1 there, well, now I can cross it out with that 1, and it makes sense. I've got the x plus 3, I cross it out there, 1, 1, that matches up, I cross it out, not thinking about what the values are. Now, again, I'm just copying x plus 1, and its multiplication, and 2, copying that, I don't care what that number is, I don't care what that number is. And I take what's left here, 1 and 5, put them together with the multiplication, because that's what I'm doing. And then the equal sign comes down, and then you're just copying the x plus 3. Again, don't care what it is. This 5x, again, don't care what it is. I'm just copying it there. Now you're left with multiplication and addition, which is easy. So in all these problems, we did the exact same process. All the problems look different. First we started with just numbers, then we had just letters, and now we've got letters and numbers. But we followed the same pattern for all of them and did equal amount of work for all of them. No matter how complex the problem looked, it was solved in exactly the same way, or at least we reduced it in exactly the same way. We took the unique denominator values, put them off to the side, and then we copied, 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 crossed out, crossed out, crossed out, copied, copied, copied. And now it's time to do the computations without fractions.